Dimension now is kilometer, meter, Celsius. So we can keep it as it is. So that means to say later when I key in the 250 meter, I'll key in 0.25. Right, 0.25. Then meters wise, so instead of 125, then I'll key in 125. But again, if you find that it's very difficult for you to do, then what you do, you convert everything to Newton and then right? So it's really up to you. So maybe I thought you use Newton and then right? So that I don't need to do a calculation myself, just simply substitute the value. Okay, then next one is this is where we stop just now, right? Because it's asking us in the X direction how many grid lines do we have. So for our case, we have 4, right? And then 3, 4, 5. Okay, our computation is 5. Remember the shapes that we're looking? It's actually 4 bay, right? So 4 bay number. So here 1, 2, 3, 4, 5. Right here 3. So in terms of grids in X direction, along the X direction, so you got 5. 5 here. Now for the Y direction, okay, where is the Y direction? Y is the one that going inside the space, right? So the default is 4, so it doesn't really matter. You can leave a 4, if not, you can put a minimum of 2. You cannot put 1 because there's no something considered with 1 with line of 1. Something like at least 2. If you think that this one doesn't bother you, then you leave it. That is 2. That is 2. Okay. What about our distance? So distance x maybe. Distance here, it means what's the gap here? Remember just now we take 500 divided by 4, right? So it's actually 125. So that one is equal to 100. Yeah. Okay, so don't worry about this sizing of it because anyway, we only be looking at exact. We are not looking at exactly. Okay, so this is the shape that I want. So this is exactly what we actually drawn on the board. Right. So far, okay. Can I? Okay, then next, okay, next we are supposed to start drawing the numbers. But of course, we need to define 2 things. One is your E value. So first thing you define like E value. Like E, and after that define our so the E value depends on what we have tested just now, right? So anyone who use the numbers that you are then I thought you do the testing. Operating for you, then you gotta go back and pick it up.
See someone for the family.
Oh, okay, I think maybe Grace. Just now you say that you send it to the other. Okay, so I'm not sure whether what's the value. Okay, let's define an example. If you say use 6 kilometers the I value depending on the size of the conductor. So okay, let's say we based on one stick, one stick is this is based on one stick, one stick. The I value becomes I E 4 over 64, right? And then 4. You remember the formula? The I value, the IXX is actually the IY1. I E 4 for 1. So, okay. Yeah. Okay, let's look at the first one first. I need to key this one, right? So what you do is you define your material. Okay, define material. So as I mentioned in the class before, first the system actually provide you with two samples, right? One for concrete, one for the for steel. So I'll use the A1, then I'll add a copy of material. Okay, add a copy of material. Okay, so the system trying to copy every parameter, right, all the data over, and then give you a material name called match MNT. Right? So of course you can change the name to whatever name you want. For this case, maybe I call it starting area, and then as you know, just now in the lab, right, what we are actually trying to gather is the E value. But you notice that this whole parameter settings, there are other values like Poisson ratio, thermal expansion. Of course, we don't care about thermal expansion, the very heat, within fan contract, so we don't bother. And all these properties are basically for the steel one, nothing to do with us. So more important, we need to bring in this box here, that's the E value. Oh. So the question is that now it is based upon Newton mm, right? So that means this number here is representing Newton mm square. Newton per mm square. Oh. So that means for our case, this is 6 kilonewton per mm square, right? So what do you think I should enter here? 6,000. Yeah, exactly. Right? So I'll go to 6,000. 6,000. So now you can see there's one material called sap2000 material. Okay, yeah. Okay, next, define section property. Right? So second property, then we say the frame section. Frame section. So at present moment there isn't anything because the computer doesn't know what about number strips we want, right? So we say okay, I'm going to create a new property. New property. And then we try to look up. Okay, try to look up. There isn't any shape that conform to what we are looking for, right? Ours is solid circular, right? So it wasn't there. That's number one. Number two, it tells us that all these are based on steel section. So we got to select others. Because it is not steel, not concrete, aluminium, not a cold form metal, right? So it is with others. Okay, so others, we say a general shape. General means can be any shape, doesn't matter. Any shape. Okay. So again, like the material is called MAT, right? So for section we give the frame section 1, right? So the second one, then section 2. So again, looking at this box, the property box, all of the data are set up to be 1, this factor 1. So we need to enter this value, right? This I value. So which one do you think goes to? It's under this box, moment initial dot 3-axis. Right? This 3-axis doesn't mean it's like 1, 2, or 3. It's not. It's actually it's a labels. Okay? It means that when the structure band, right? The structure band, the axis is bending to the y-axis, right? It's about y-axis, right? Rotate about y-axis. So that axis is called the 3-axis. It's this software. So for other software, it remains the value. So you must know which box is in, because otherwise you will get a result. So we need to change this one to something else. So this one has to be changed to this value. This value. So we got to calculate this value. So use the calculator. Yeah. Okay, remember this is meant for only one number, right? So it's
3.976. 3.976.
3.976. So 90 lah. Okay, so 3.98. So this is over here. 3.98. Okay, next. Okay, this one I'm going to change it to instead of frame section 1, I'll make it a frame 1. You can call any element you like. Okay, and don't forget to set this area. Okay, to So do you see the meaning of this relationship between what you set in this property of the 3.98, right? Here is set 3.98, and at the same time you find the tell the computer that for this material, for this section of 3.98, it is going to be using a subject material. Otherwise, you take it as T. So you return back from the now So maybe as you design accordingly, like you're not sure whether at the end of the day whether I do all single member or maybe some of two or three, right? So maybe it's good to look up 3, 2, 6, 3, 6, 4, 6, and so on. So in this case, let's assuming that you have 2, 6, right? 2, 6. Let's say 2, 6. You can actually join this manner, right? Side by side, or you could join this way in that. So theoretically, do you think there's a difference in terms of their I-axis? The way you orientate it, yes, right? If this is my x-axis, and this is my x-axis, the I-axis and this I-axis definitely not the same. Which one got more? The first one. Which one got more? First one or second? The second one, yeah. Second one got more because for second one, every member has this offset vector, right? In other words, for this case, for this member, the I-axis is basically I shore was equal times 2. Right? That's simple. Whereas for this guy, the I-axis is equal to I d4 was equal to 2 times 2, but you have to plus area times the scale of delta square times 2. So you can see that this one definitely more than this, right? Because there's the offset distance. So in this case, if you really want to work in a very theoretical manner, you must decide that, okay, if you're using two members, whether do you want to tie this manner or you tie this one on top and bottom. Because you affect your eyes. But for simplicity, right? For simplicity, you say, okay, can we say that we don't bother whether it is this way or this way? Take it that it is this one times 2. Right? And this one times 2. Then you ask yourself, is it okay that if for this case, I assume that it is this one instead of plus another component? Is it okay? Is it okay to assume that for this one, I ignore this portion? Is it alright? Is it okay? Okay. I would say no, but why not? Why is it not okay? Okay. Is that alright? Is that okay that okay about this one? And even I arrange my statistic in this manner, just take ID4 the other time 2. Must I do this? I do that. Not if I do it. It's okay. Does it cause any problem for me? Or what's the consequence if I ignore it? What's the consequence? What's the consequence? Lesser value, right? Okay, lesser value. Okay, because you ignore this one, so your I value, you supply less than what it should be, right? Then you ask the next question, is it okay? So you answer this question, then you ask another one more question. When you ignore this portion, are you under design the model or are you over designing? Under design, right? Under design. So is it good or bad? Bad. Bad? Good. It's good. It's good. That means to say that if I put it in, the model should perform better. But now I take it out. Right? The model doesn't perform well virtually, but in reality it should perform better. Right? So in my modeling, I design is okay. Because I know eventually when I do the real one, I do like this,